Okay, moving on to the next page here. It asks us to find the medians for brand Y and Z for number 1 and then compare the two. Oh man, I wish I'd thought about this before I made these graphs because I made brand Y a very large number of raisins. So if I look back, how do I know this information? Okay, so I'm going to scroll up for just a second to look back at the graphs I made. Okay, I know that there are 3 boxes that had 25. So when I'm listing this out, I have to have 3 25s. I have to have 4 26s. I have to have 5 27s. I have to have 6 28s. Okay, and you kind of notice that's what these numbers are for right now. I have 5 29s, 4 30s, and 3 31s. So if I scroll back down here, basically you'll see that's what I've done. Okay, and it asked me to compare the medians. I did have an even number of boxes here in brand Y, so my median ended up being in the center here at 28. I had 2 28s. Obviously, the middle of 28 is still 28. Okay, yes, this would count as still the lower half, and yes, that would still count as the upper half. Okay, in brand Z, I had an odd number, okay, which meant that I was going to have a single digit in the center, and when I marked them off high, low, I ended up with 30. Okay, 125, 126, 127, 2 28s. Where did that come from? It came from this graph. 125, 126, 127, 2 28s, and so forth. Okay. So I have a median of 28 here. I have a median of 30 there. It asks if the medians were the same as the number that occurred most often. In the Y brand, yes, 28 was the mode, and it was also the median. Notice that also was the symmetric data. Okay, this is one reason why, if you've had statistics, if you've taken 111, that you're really going to see a bell curve data we do so many things with, because it is a situation where we expect the mean, the median, and the mode to match up pretty well. All 3 of those things are descriptors of the center, okay, which is why we use mean, median, and mode. Okay, in brand Z, it was not. Notice that brand Z was not symmetric. So the mode and the median did not match in that particular situation. It asks in each one of these, which is the better measure of the center of the data, and which is the better measure for a typical number. Okay. In graph Y, okay, that is definitely going to be, both of those are going to be the median, because the median and the mode are both equal. However, when you get up to brand Z, that kind of depends on what you mean by typical. If we really want to know kind of where we should expect our raisin count to be, obviously somewhere up here, okay, is where the majority of those results are. We did have a median of 30, but we had a mode of 31. Okay, mode's probably not a good indicator there either, because out of all of these, only 6 of them had 31. Every other box was below that. So the median is probably a better descriptor in both of these cases. Okay, a typical number. Remember, we're trying to think of what would describe a set of data well if we can only use one number. Gosh, guys, a lot of you probably might be happier with median grades instead of mean grades. Medians are not subjective to outliers. Okay, so if you get a few scores that are really low and then one grade that's super high, your average is artificially inflated. Okay, your typical performance is a little bit lower. Whereas if you normally get 4 or 5 A's and then you get a 0 on one test, your average would be artificially deflated, whereas your typical performance would be a little bit better than what your average says. So that's kind of why median, when data is skew or not very symmetric, we kind of go with median as a better descriptor, because it's not influenced by those really high or really low values. Okay, so is there a way to find the median just seeing the bar graph? Yes, it goes back to this idea of the median is in the middle. If we know the number of responses for each value, it's going to be easy to find the middle. Okay, so if we have an odd number of data, we know it's that one value in the middle. We have to have the same number above and same number below. So think about when we had those 15 boxes of raisins up here. Okay, I knew that we had an odd number and it had to be 15. So one of those 15 was going to be that one in the center, which gave me 14 other values. And I had to split them evenly. So I know I had to have 7 below, I had to have 7 above. If it was not an odd number, it was going to have 2 in the center. Okay. In this case, this had 14 data points. 1, 2, 3, 4, 5, 6, 7, and 8. Those were the 2 centers. So if I have an even number, I usually just split it in half. Okay, if I split 14 in half, that would be 7. So I know the 7th and the next one are going to create the boundaries between where the center is when I have an even number of points. Okay, so can I do that? Sure, I can. Okay, if I went back up to that graph, I want you to think about this. I have 3 low and 3 high, so those would kind of balance each other out. 4 low and 4 high, those would balance each other out. Okay, if I count this, I have 7 plus 5 is 12, plus 6 is 18, plus 5 is 23, plus 4 is 27, plus 3 is 30. Okay, so that's an even number. So if I split it in half, that's 15. So somewhere between the 15th and the 16th number is where the median's going to be. So let's count up. There's 3, 4, 7, 12. We know the 15th and the 16th number are going to be in here. Okay, so that's where the median is. Over here, let's think about this. We have 1, 2, 3, plus 2 is 5, 10, 15, 21. Okay, so an odd number here. One of those values is going to be the median, and then I've got 20. The other 20 I have to split, so I'd have 10 below and 10 above. So that means the 11th value is going to be my median. If I find the 11th value, it's somewhere in this column. Okay, 1, 2, 3, 4, 5, 10. That's 10 numbers. So the 11th one is somewhere in here. Okay, I can do that by just looking at the bar graph. Now, this is the data that we had in the last session where people estimated like how long a minute was. So that data was taken and reported here in a stem and leaf. And it asked us to find the 3-number summary. So a 3-number summary is just the bottom, the top, and the middle. Okay, so that minimum is pretty easy to find. That's 33. Maximum is 86. Okay, now what about the median? When I count this, there's 26 data points. Okay, so that's an even number. Split 26 in half, that's 13. So between the 13th and the 14th, that's where I'm going to find the data points. I could mark them off here. High, low, high, low, high, low. I could keep doing that until I found my center. Now this is the 13th and the 14th point. Okay, it's 60 and 63. So I could add them up and divide by 2. I also could ask myself, there's a difference of 3. Where's the middle? 1.5. So 61.5 is my median for this one. Is the median the data value that occurs most often? No, it doesn't occur at all here. If we look at the mode of this one is 52. Okay, so we have 1, 2, 3 results that are 52. So which value is most representative of the data? Absolutely the median. Okay, the mode is kind of on the lower end of the data. If this was somebody's grades, they wouldn't want you to give them a 52. Okay, that 52 would not be representative of what their score typically is. The 61.5 would be a better fit for that because it's more in the middle. Okay, the mode is lower than most scores. So given the 3-number summary for a collection of this data, what do you know about the data from that summary? Okay, I know that it spans from 35 to 75. Okay, so the lowest it can be is 35, the highest it can be is 75. The middle result is 63. So half of these results are going to be between 35 and 63. Okay, and the other half are going to be from 63 up to 55. Okay, that's what I know just from that 3-number summary.